Here's the phase shift of the AC input. See right, looks like about 2 spaces horizontal for the phase shift. For one zero line to zero line of a complete phase, it looks like 8.5. Maybe 9. Okay, I'm going to wait right now. I'm going to say 8.5. A little bit over 2. So, one sine wave is about 8.5 small spaces, which you'd call minor square divisions, the 5 spaces in between a square division. And so the 8.5 would represent horizontal 8.5 spaces. It represents 360 degrees. Okay. This is the AC input from the grid, and this is the current. It looks like 15, 16, 17. One moment. Okay, when I look at this with my eyes, it's very clear, but this digital camera I have in my smartphone, it picks up these flashes. These are like in my earlier videos. But anyways, peak to peak on the current is 18 small little spaces here. Okay. And you need to know that to calculate the current. And I'm in the current, this is the amps. And this is in the .02 square division. So that means each of those larger squares, each of these, is equal to 0.02 volts. Okay, so from that you can calculate the amps, the current. Now, here's what's interesting. My video before, when I put a cap parallel to the primary. So here's a primary wire. Here's a primary wire. And it was a 4 UF cap, if you remember my previous video, that made the draw go way down. So, you see this? One is on one primary. When I put this over here on the other primary, now I have a 4 UF cap in parallel to the AC input parallel to the primary input AC wires. Now look what it did to the voltage. That's that fuzzy one. And it seems like there's no phase shift really now. Maybe a little bit to the right, but not much. There's a little bit. And look how it knocked the current down. The current, that's the current without a parallel cap. This is a current with it. It's kind of fuzzy. But let's try a 3 instead of a 4 UF. Now I have a 3 UF. That also knocked the current down. Here's the current without it. Current with it. But the 4, when you look at what the meter says, it was the 4 that really brought the current down. And that's what that is. Okay, let's put this, for the fun of it, in series. This 4 UF cap, put it in series. So that, let me just fix this up one moment. There's what it looks like with nothing going on, just AC input into it, but no caps in series or parallel. Now, one moment. Oh, this is interesting. When I put a 3 UF cap in series, this is 3 UF right here, and it's in series. That's the current now, and it affects how the voltage looks too. This is the voltage. And here it is without it. Just a moment, there's something messed up here. Sorry about that. Okay, now we got something going on. Now, this is with just the, there we go. This is the current here. Notice the voltage is leading the current. Also, I forgot to mention when we did the 4 UF cap in series, it made the capacitance lead the voltage. The amperage lead the voltage when you add the cap. So let's see, I'm trying to get these so they're kind of in the middle. There we go, I like that right there. Okay, so there's the phase shift. Now we're going to put a 3 UF cap in series on one of the AC lines. And here's what happens. Here's without it. Here's with it. And this is the current. So it raises the current quite a bit. There's still that phase shift. Looks like it made a bigger phase shift now. Looks like about three spaces. Let's go back to nothing. Here's with no 2UF cap in series. Here's with a 2UF cap in series. So it really makes a bigger phase shift. See that? So let's put this over. So it makes more amp draw. Again, the amp is this one. That's the amps. And let's look at it one more time. This is with nothing, no cap in series. Here's a 3UF cap in series. Now let's go over to a 4UF cap. This is going to do something, I bet. Whoa. Look how much power I make now. 41.6 volts across a 50 ohm resistor. Now, there's tons of voltage being drawn. In fact, I'm going to have to turn down the... There we go. I turned this to 0.05 volts per square division. Now, where's that phase shift? There it is. Okay. Let's look at the difference. Here's with, without a 4UF cap in series. And this is with 4UF cap in series. Notice this is the amperage. And notice it's a little bit leading to the voltage. Because this one, see that way? Leading would be more to the left. There's still a big phase shift. Now, okay, let's see. This is without any cap in series. There's no 4UF cap in series. This is the current here. And it's now not leading. It's definitely the voltage is before the current. But when I put a 4UF in series, now the current is actually leading the voltage a little bit. So, a cap in series messes with which voltage or current is leading. Now we have a 3UF cap here. Here's the voltage. Excuse me, this is the current. Now there's quite a bit of current leading the voltage. See that? All this I'm doing has a gigantic phase shift going on. Here's with nothing. Let's go back to just, hold on. I'm going to make the, you want to have the voltage and current forms centered on that zero line. So I'm going to do that. Now I'm going to change, that's kind of a good one. I'm going to go for a big one like this. And I changed what the square divisions are. So here we go again. From this you can look and see a complete sine wave from 0 point to 0 point. It's probably around 9 if you count it out. 8.5, I'd say. While the phase shift right there is like a little bit more than 2, I'd say. So that's like 90 degrees. This is all a 90-degree phase shift going on. So I can play around with more and more current input, more and more volt amps reactive in, but the watts, if it's 90 degrees, it's going to be a power factor of 0. So, whatever. Also, the output, see, I always have a resistive load going on when I'm doing this from the secondaries. And it is 16.2 volts across a 50 ohm resistor. And so when I put a 4 UF cap in series, let's see, that would be this one. You hear it kind of growling. And it's got massive amp draw now. I'm in 0.05 volts per square division now. Also, it makes a, see the phase shift? It kind of becomes pointy. Both the volts and the amps down here. Well, it's curved on top. Not sure what that means. I assume it's some sort of saturation thing. But anyways, 41.8 now in real power coming out across a resistive load. It's getting hot. I can put it in this one, but I'm just going to keep it there. So, when I put a 4 UF cap in series, I'm making quite a bit more power at the expense of more amp draw. However, it being a phase shift of this much right there, that's 2 spaces. So it's an almost 90-degree phase shift still. Because if you have 8 spaces for 360 degrees, that's 45 degrees per little space there, 45 degrees, each of those going horizontal. And if you have 2 of them, that's 90 degrees. See? Look at that. And so I think this is about 9 spaces. Let's see. Oh, it's more now. Looks like it kind of slowed the phase down. What's going on here? I'm sorry if this is boring, but you know, some things in life are boring. So, here's with no 4 UF cap. And I'm making 6.2 across that. 16.2 across the resistor, okay? This is just AC feed to the primary of this hemmoroidal transformer with a resistive load of 50 ohms on the secondary. There's that phase shift. It's a good phase shift. Now, let's put this in parallel. This 4 UF cap again and look at it in parallel. Let's see, hold on one moment. Okay, I've been messing with the dial, so it's actually 13 spaces now. Horizontal for one phase sine wave, one sine wave from the zero line up, down, and then back to the zero line. I count about 13. Wow. It's now 3 here. So let's do the math real quick on what the phase shift is. This is without any capacitor in parallel or in series. One moment. Looking with my eyes at this, it seems like it's a little bit over 3. The space of the phase shift, and the and it's 360 degrees is going to be 12 spaces. Say 12 and a half. So it's 360 degrees divided by 12.5 equals this. Never mind. It's up around 90 degrees. Maybe 83, somewhere around there. This is without any cap. So let's put the cap in again, in series. The amps jumps off scale. I got to turn it down to 0.05 volts square division. The comes pointy at the bottom, still curvy at the top, the sine wave. And there's still a pretty good phase shift. You're supposed to measure the phase shift right here. So now I'm going to do one last thing and then I'll call it a day. It's 24 minutes. I want to put a parallel 4 UF cap again. One moment. Okay, I did it. This 4 UF cap is in parallel to each primary AC leg. And we have this for the amps now. I take off one of these, so it's not parallel anymore, we have that for the amps. Then we have this for the amps. That for the amps. This for the amps. With the 4UF in parallel. That'd be called power factor correcting. Let's put the amps up like that. Okay, this is amps with excuse me. This is amps with no paralleled 4UF cap. There's that phase shift. Now I'm putting a 4UF cap in parallel, and look how the amps looks now. And there's just a little bit of phase shift over here. More or less there's no phase shift. Okay, this is good enough. Thanks for watching.